Okay, we're going to work on converting rectangular points, so xy, to polar points, radius theta. So imagine if you graphed a point on an xy graph, say right here. Well, if all of a sudden you laid a polar graph over it, that point would now be on a polar graph. So those two things relate to each other in terms of location. I'm now going to show you how you figure that out. So if you are given the x and the y value, how you find the radius is the square root of the difference between, if you're just given x and y, it's x squared plus y squared. If you're given 2 points, say you're given 5, 3, and I don't know, 2, 1, something like that, it's the difference, right? It's the radius is like the hypotenuse, right? If you were to draw that circle, that's a terrible circle, but the radius would be the hypotenuse of a right triangle, so it's x squared plus y squared. And sometimes you have to set it up in this format, but for now, let's just look at this right here. And then theta, well, tangent of theta is y over x, because this is opposite over adjacent. But to get the theta by itself, we would take the inverse tangent of both sides. So from here forward, to find theta, you just set it up like this. Inverse tangent, the y value over the x value. So let's do an example. Well, here's one example. Let's say your x and y is 1, 0. Well, if you look at your unit circle, you have this point. That point is at 0. It also is at 2 pi, but if we're talking about the first go around, that theta is 0. And what is that hypotenuse if it's on the unit circle? The hypotenuse is always 1. So even though they look identical, this is now the radius, and this is 0 pi or 0 degrees. But let's set it up in this format. So if we want to find the radius and we didn't think about looking just at the unit circle, here's our x, here's our y. So the square root of x squared plus y is 0, squared. Well, 1 plus 0 is 1. Whoops. The square root of 1, in terms of the radius, we'll just take the positive value as 1. And then theta would be inverse tangent of 0 over 1. When you type second tan into your calculator, second tan 0, you're going to get 0. So in this case, theta is equal to 0. Radius is equal to 1, and that's what we have right there. Here's our r, here's our theta. Let's do a different actual example. All right, so we're given the x and y. You could almost guess by looking at this what degree that would be, because look at, those are almost identical terms. One's positive, one's negative. And notice that's a positive x and a negative y. So that means we are in the fourth quadrant. So that just gives you a perspective when you're finding the theta to confirm if you wrote the correct one. So the radius is the square root of the x value squared plus the square root of the y value squared. So when we square this 2, we get 4. When we square the square root of 2, we get 2. So that's 4 times 2. And over here, negative 2 times negative 2 is also positive 4. And now we have 4 times 2 is 8. We have 8 plus 8, which is 16. And the square root of 16 is 4. All right? Now we go to find the theta. Remember what we said. Find the theta. You take the inverse tangent of the y value over the x value, because tangent is opposite over adjacent. So we're going to set it up like this. And look at any number over itself is positive 1, but this is a negative something over its positive self. So we have inverse tangent of negative 1. When you plug that in, you're going to get negative 45 degrees. And negative 45 degrees, if you look on your unit circle, that's the same as 7 pi fourths, or 315 degrees. So I'm going to put it in radians. So did we find our radius? Our radius, change this to blue. Our radius is 4, and our theta is 7 pi fourths. All right, that is how you convert a pair of rectangular coordinates to polar coordinates. And by the way, this was an important domain restriction that I did not mention. Remember, this theta is coterminal with infinite angles. This tells you the only theta that we care about is between 0 and 2 pi. All right, that's it for this one.